Hi, good evening to everyone. As you know, this is Arun. I'm a physics faculty since 9 years, and I have been teaching in this segment of KCET and NEET since almost 9 years. And yes, in today's class, I'm going to continue the concept of motion in a straight line of level 1 and level 2 problems. Fine. Now, so before I go ahead, I would like to give you a brief idea about the Unacademy Plus subscriptions. One is the best plan for Karnataka KCET is aspirants is 2021. That is for 12 months. For 12 months course, you can opt for a rupees of 12,375. For 6 months, it is 10,125. And for 1 month, if you want to check out how exactly Unacademy works and how exactly the lecturing would be, you can think of taking off 1 month plan at the rate of 2,250 only for new subscribers. If you want discount, you can apply with the user code of Arun K Live, so that you are going to get 10% discounts. So what are the things will be available? Obviously, the premium content at the affordable price, structured live courses, plus dedicated live doubt clearing sessions, quizzes at the regular interval of time, batches for complete preparation. So what's the batches for complete preparation? You're going to see in the next slide. The test series for DPPs, full length mock test, etc. with analysis, and single subscription for unlimited access. You can watch, there are so many faculties available. You can watch all those videos without any, restrictions. Right? As I said, there is a comprehensive batch. There's a comprehensive batch for Karnataka KCET 2021, and this has begun from September already. Right? It has already begun from September 1st. The complete syllabus will be covered on this. So they are already live in the Unacademy Plus. You can have a look at that. Topic-wise practice questions, full-length mock tests, and the obviously about subscription. That is for 1 month. It is 2,250 only till the end of September 30th. Right? You can grab it. Yes, Farviz, hi. How are you? Hope you're doing good. Okay. So let me start. Let me continue the questions where I have left. So let me have a look at it. A particle starts with a velocity. A particle starts with a velocity of 2 meter per second. A particle starts with a velocity of 2 meter per second, and it moves in a straight line. With a retardation of 0.1 meter per second square. The retardation of 0.1 meter per second square. The first time at which the particle is 15 meters from the starting point. The first time at which the particle is 15 meters from the starting point. Right? Let's have a look at it. How to solve this question. There is a small trick in the question. I'm going to tell you what exactly that trick is at the end of the solution. Right? So we can see a particle is going to begin its journey with a velocity of 2 meter per second. So I have what is the value of initial velocity, that is 2 meter per second, right? And it is going to move in a straight line with a retardation of 0.1 meter per second square. So I have an acceleration of 0.1 meter per second square. The first time at which, this is the twist I'm telling you, the first time, they are not asking you at second time or third time, at the first time at which the particle is 15 meters from the starting point. Let us see how exactly to solve this one. Yes. So obviously you are supposed to find the time. You have displacement, you have acceleration, you have initial velocity, right? So displacement is 15 meters from the initial point. Acceleration is how much it is? It is 0.1 meter per second square. 0.1 meter per second square. Whatever the initial velocity? Initial velocity is 2 meter per second. Initial velocity is 2 meter per second, right? So let us see now. 2 meter per second, right? Now, So displacement is equal to ut plus half at square, right? Where so I have given you a clear idea when to use, when to use which equation, right? So the displacement is 15 meters, initial velocity is 2. I don't know what is the value of time, so it is 2t plus half into acceleration is minus 0.1 since it is retardation, right? So it is t square, right? Now I can write this one as, you know, uh, 15 is equal to 2t minus 0.05 t square, right? Or simply I can write this one as, 0.05 t square minus 2t plus 15 is equal to 0, right? Now I can take out 0.05 so that I can get the value of t. So t square minus see, this would become 5 10 power minus 2, so it comes, numerator becomes plus 2, so it is 200 means it is 40t plus, so it is 3, so it is 300, that is equal to 3, right? So I am supposed to factor on this one, or simply I can use the value of t here. T is equal to minus b, right? Minus b means minus of minus b is plus, so it is 40 plus or minus square root of b square minus 4ac, right? B square, 40 square, right? 40 square is 1600 minus 4 into a is 1, c is 300 divided by 2, right? So if I simplify this, t would be equal to 40 plus or minus square root of 1000, 600 minus 1200, it would be square root of 400 divided by 2, a is nothing but 1, so it is 2, right? So t would be 40 plus or minus 20 divided by 2, right? So I can simply write this one as, if you take out 2 common, so 2 and 2 will get cancelled, t is equal to 20 plus or minus 10. So time can be 10 seconds or time can be 30 seconds, right? Yes, both are positive, right? When both are positive, which answer to be considered? When both are positive, which answer to be considered? Now, I said I am going to tell you what is the twist. That twist at the last of the solution. No, try to understand it. So it has begun its journey from this origin. It is retarding. So it has reached a distance of 15 meters. Let us see. Correct? Now, once it has reached a distance of 15 meters, right, since it is retarding continuously, there may be a possibility that there is an opposite force applying on it. So what happens? The particle may go to initial and then it can travel 15 meters on the opposite side, right? If it takes 10 seconds to come here, then coming back to 0, 10 seconds, then from 0 to 15 meters again 10 seconds. So how much is that? 0 to here it is 10, then it is 10 again 20, from here to here it is 30. So total time taken is 30 seconds from the other point, on the other side, right? I need the first point, I don't need the second or the third point, I need the first point. So this must be this one. So it takes how much? It takes 10 seconds to reach the first 15 meters of its second, right? That's option A must be your answer. Option A must be your answer. That is, S is equal to 10 seconds. So T is equal to 10 seconds. Next. A simple question to be solved. The next one. As I said, these are the level 1 questions. We are going to counter for the level 2 questions at the earliest possible time now. If a stone is thrown up with a velocity 9.8 meter per second, if a stone is thrown up with a velocity 9.8 meter per second, then how much time will it take to come back? A simple question to solve, right? See. I'm throwing a stone up with a velocity of 9.8 meter per second, right? So this reaches the maximum height, it is going to come back, right? It is going to reach the maximum height and it is going to come back, right? I need what is this time taken, right? Right, honestly, if a stone is thrown up with a velocity 9.8 meter per second, then how much time will it take to come back, right? So I can clearly say time of ascent is equal to time of descent. If I find time of ascent, I can easily find time of descent because same is the time of descent. How do you find? P is equal to U plus AT, right? Because when it reaches the maximum height, what is the value of final velocity? It is 0. Initial velocity is given, it is 9.8. Find the value of time, right? So 0 is equal to U is 9.8 plus 9.8, or simply 9.8 into T is equal to 9.8, or T is equal to 1 second. If time of ascent is equal to 1 second, then time of descent is also equal to what? 1 second. What is the total time then? Total time is 2 seconds. Is that clear, everyone? Yes. So the answer is option B, that is 2 seconds. Right? Next. Now, a particle starts from rest. Accelerates at 2 meter per second square. For 10 seconds. A particle starts from rest, accelerates at 2 meter per second square for 10 seconds, and then goes at a constant speed for 30 seconds. Then deaccelerates at 4 meter per second square till it stops. What is the distance traveled by it? I would like to draw a simple graph so that you can understand it clearly. Fine. Since the particle is beginning its journey from rest, right? It's going to accelerate. Just a second. It's going to accelerate for 2 meter per second square continuously. For how much time? For time of 10 seconds, right? For the time of 10 seconds, it is going to accelerate continuously, right? Then goes for constant speed. See, if I draw this one as VT graph, right? Then goes for constant speed for 30 seconds. For 30 long seconds, it's going to move the constant speed. The velocity is not going to change, right? Now, then deaccelerate for a rate of 4 meter per second square. So this would become 40 seconds then. 4 meter per second square till it is going to come to rest, right? Now, what is the distance traveled by it? So what is the total distance traveled by it is the question. See, it is going to begin from rest. So for the first case, there is from A to B, right? For A to B, distance traveled in A to B I can find, right? So it is nothing but ut plus half A into t square, right? So what is the initial velocity? 0. Acceleration is 2. T is 10 seconds. So I can write 2 into 1 by 2 into 10 square is 100, or I can write it as 100 meters. So initially it is going to accelerate for 100 meters. Then it's going to move. It's going to have a constant velocity for how much? 30 seconds. So to find the distance traveled by it, I am supposed to know what is the value of its velocity, right? So just simple, v square minus u square is equal to 2u, right? Initial velocity is 0. I can find what is the final velocity. That is the velocity at the end of this one also, right? So v square is equal to 2 into acceleration is how much? It is 2, right? Into distance traveled is 100, right? So v square is equal to 400, or v is equal to 20 meter per second at the end of this one. So here the velocity is 20 meter per second, right? So the velocity is 20 meter per second. Now, at the rate of 20 meter per second, it is going to move for a constant time of how much? It is going to move for a time of 30 seconds. So the distance traveled would be, yes, from say it is B to C, yes, BC would be equal to C. ut obviously directly because a is 0, so it is 20 into 30. So yes, along BC would be equal to 600 meters. So the distance traveled here is 600 meters, right? In this case, right? Let us find the final one now. Now I am supposed to find what is the value of displacement. Yes, and I know that the final velocity is 0, but the initial velocity for this case is how much? It is 20 meter per second, right? So v square minus u square is equal to what? 2a second, right? So final velocity is 0, initial velocity is how much? It is minus 2u square, that is 20 square, it is 400, that is equal to 2 into a is minus, because it is deaccelerating, it is minus 4, displacement I want to know. So yes is equal to 400 divided by 8 or is equal to 50 meters. So during CD the distance traveled is 50 meters, right? Hagadre, the total distance traveled is how much? 100 plus 600, that is 700, 700 plus 50 it is. So total distance traveled is 750 meters. Do you have any doubt, guys? You can ask me over the chat box if you have any doubts, please. So the total distance traveled is 750 meters. That is option A must be your answer, right? So you can do fast as in when the time proceeds. You can do very fast, right? So since it is the beginning, I'm just trying to train you and trying to explain you everything. So it is taking a bit of time, right? So apart from that, it is not a time consuming question. You can solve it within 1 minute. Nothing to worry. Fine. Next. Fourth one. A body dropped from the top of the tower covers a distance 7x in the last second of its journey. Covers a distance, 7x in the last second of its journey, where x is the distance covered in first second. Where x is the distance covered in first second, right? How much time does it take to reach the ground? How much time does it take to reach the ground, right? Now a simple question, right? So as I said, we have 4 equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square minus u square is equal to 2as, and the last one Sn is equal to u plus a by 2 into 2n minus 1, right? That is nth second, right? Now since the body has been dropped from the top of the tower, it is going to travel a distance of 7x in the last second, right? So let me write a diagram so that you can understand it. Yes. So you have dropped from the top of the tower, right? The distance traveled in the first second is x, and the distance traveled in the last second is 7x. Fine. Now, so let us apply Sn equation. Sn is equal to u plus a by 2 into 2n minus 1. Right? What is the distance traveled in this one? Distance traveled is what? 7x. That is equal to, see, initial velocity. What is the value of initial velocity? Dropped, so it's 0. Right? A by 2, nothing but g by 2 into 2n minus 1, where n is the time. N is the time. Right? Now, let us apply one more thing. What is this mean? Where x is the distance covered in first second. Correct? Hagadra. S is equal to ut plus half at square. What does this give? Then let us see now. Distance traveled is x, initial velocity is 0, time taken is 1. So x value is g by 2. X value is g by 2. Am I correct? If x value is g by 2, let us substitute in your equation number 2. So it is 7g by 2 is equal to g by 2 into 2n minus 1. G by 2 and g by 2 will get cancels. So 2n minus 1 is equal to 7, or 2n is equal to 8, or n is equal to 4. Right? As simple as that. Simple tricks. Simple, very, very simple tricks. Right? So the total time taken to reach the ground is 4 seconds. Right? Next. A body is moving with a velocity of 8 meter per second. A body is moving with a velocity of 8 meter per second. When the body just crosses the another body, the second one starts and moves with a uniform acceleration of 4 meter per second square. A body is moving with a uniform velocity of 8 meter per second. Fine. When the body just crosses the another body, the second starts and moves with a uniform acceleration of 4 meter per second square. The time after which two bodies meet will be a simple question, a very very simple question. Right? Let us see what is this. Right? So there is a body A and there is another body B. Right? This A is moving with the speed of 8 meter per second. Right? Is moving with a uniform velocity of 8 meter per second. Fine. When this crosses this B, with a velocity of same velocity, because uniform velocity is nothing but it is going to maintain a constant velocity, right? When this crosses B starts its motion. That is, moves with a uniform acceleration of 4 meter per second square. This is going to move the velocity of, acceleration of 4 meter per second square. Right? So now, after traveling this particular distance, say at this point P, say A as well as B are going to meet. After a time interval of T and traveling particular distance at a point P, both are going to meet. Right? Now, what I'm supposed to find? The time after which the two bodies meet, you're supposed to find, right? So I'm supposed to find what is the time after which the two bodies are going to meet. Correct? Now, see, both are going to travel the same distance. Yes. Correct? With the time T. Correct? Because after crossing this one, the B has already zero. So after traveling the time interval of T itself, A is going to meet this point and B is also going to meet the point. Right? But what is the difference? A is moving with a constant velocity of 8 meter per second. Meanwhile, B is moving to accelerate with the acceleration of 4 meter per second square. Right? Now, so for A, let us apply now. Since it has traveled at time T, so S is equal to ut plus half at square. Distance is same anyway, ut plus half at square. Right? For A, right? Time is same for both, but acceleration of A is 0 because it is moving with a constant velocity or uniform velocity. So yes A, let it be x is equal to u is 8 into T. Similarly, for B, it is going to begin with the initial velocity because initial velocity of 0 because it was at rest. So SB is equal to 0 plus half 4 T square. What is this SB value? It is x itself. X is equal to 2T square. So you can compare both because both are equal to what? X itself. So I can write 2T square is equal to 8T. T and T will get cancelled. Or 2T is equal to 8 or T is equal to 4. A simple question though. If you understand it properly, it is very simple. Else it looks bigger. That is option B. That is 4 seconds is your answer. Right? Next. Two bodies A and B starts from rest. Two bodies A and B starts from rest. From the same point with a uniform acceleration of 2 meter per second square. With a uniform acceleration of 2 meter per second square. If B starts 1 second later, then the bodies are separated. Right? See, there are two bodies which are beginning from rest. From the same point with a uniform acceleration of 2 meter per second square. Both are having a uniform acceleration of 2 meter per second square itself. If B starts 1 second later, If B starts 1 second later, then the two bodies are separated. The two bodies are separated at the end of next second by. Then the two bodies are separated at the end of next second by. Right? Andra, what is the distance they have got separated after that 1 second? Right? Now, say there are two bodies again, A and B. A will begin this journey, right? B will begin 1 second late. So after 1 second, whatever the distance traveled by A, that is the distance between A and B. Am I correct? So what is the distance traveled by A? Simple, no? As I said, whatever the distance traveled by A in 1 second, that is the separation between A and B in 1 second. Correct? SA is equal to half, ut plus half at square. So anyway, it is u is 0. So acceleration is 2, right? So have a look at here. Yes, acceleration is 2, right? Time is 1. So half into 2 into 1 square. So 2 and 2 will get cancelled. So SA is equal to what? 1 meter. So in 1 second, A has travelled for a distance of 1 meter. Right? So then, what is the separation between A and B? It is 1 meter. As simple as that. Right? That is option A must be your answer. Next. A body travelling with a uniform acceleration crosses 2 points A and B with the velocities 20 meter per second and 10 meter per second. Try to understand the problem. A body travelling with a uniform acceleration crosses 2 points A and B with the velocities 20 meter per second and 3 meter per second. 20 meter per second and 30 meter per second. Right? Now, the speed of the body at the midpoint of A and B. The speed of the body at the midpoint between A and B. Simple, no? How to find that? Simple. You have 2 points, A and B. This is A, this is B. Fine? Now, the particle is crossing this 2 points A and B with a velocity of 20 meter per second and 30 meter per second. Right? So, at A it is crossing with a speed of 20 meter per second and 30 meter per second. Right? Now, the speed of the body at a midpoint of A and B. I want to know what is the speed at this particular point. Fine? What is the speed at this particular point? Is that clear? Now, what are the things I know? See, it is traveling with uniform acceleration. It is not uniform velocity, it is having uniform acceleration. It is having an acceleration. Right? Since it is having an uniform acceleration, right? And I know what is the velocity between 2 points, that is 20 meter per second and 30 meter per second. That's the only thing I know. What is the distance between A and B? I don't know, right? So how to find this one? Think now. Just try to think now. Fine? So if you start thinking, you may end up in telling me that I need what is this? Yes, either displacement or time, right? You may end up in telling that. So, sir, I need either the value of displacement or I need what is the value of time, right? So let me consider the distance between A and B is D, or the distance between A and B is, yes, let me consider, right? So if I consider D is the distance, I can clearly write initial velocity at A is 20 meter per second, final velocity at B is 30 meter per second. So it is V square minus U square is equal to 2AD, right? I can write 30 square is 900 minus 20 square is 400, right? That is equal to 2a into d, or 2ad is equal to 500, or ad is equal to what? Ad is equal to, it is 500 divided by 2, that is 250. A into d, that is acceleration into distance, is given by 250, right? So if the car is at midpoint, right? I don't know what is the value of final velocity. Let me call this v itself, right? However, what is the value of distance traveled? It is d divided by 2, correct? Now let us find what is the value of the velocity at d, right? So it is v square minus u square is equal to 2a into s, right? So v square minus u is 20 square, it is 400, right? It is 2a into d by 2, correct? 2 and 2 will get cancelled. Now v square is equal to, it goes on the other side, ad plus 400. I can write v square is equal to 400 plus 250, or v square is equal to what? It is 650, right? 650, or you can simply write v is equal to square root of 650. How much is the square root of 250? See, 25 square is 625, right? So it must be 25.2 or 3, 25.3 meter per second. As simple as that, right? Yes, 25.5 meter per second. Option B must be my answer, right? I was not knowing distance, I was not knowing the time, acceleration also, and I was not knowing the time also, right? So how did I find? I consider it as distance d. I just solved it for a given case. Next, applying it for the midpoint. As simple as that, right? So is that clear for everyone? Is that clear, guys? Preeti Badigare, hi, how are you? I hope you are doing good. Thank you. Are you following, Preeti? Are you following the class? Okay. So let me go with the next question. A man in a balloon rising vertically with an acceleration of 4.9 meter per second square. A man in a balloon rising vertically with an acceleration of 4.9 meter per second square releases a ball 2 seconds. Releases a ball 2 seconds after the balloon is let go from the ground. Right? After the balloon is let go from the ground. Fine. The greatest height above the ground reached by the ball is. The greatest height above the ground reached by the ball is. Try to understand the question now. Simple question, but looks very complicated, right? So you have a man in a balloon rising vertically with an acceleration of 4.9 meter per second square, right? So you have a man, right, sitting in a balloon, right, rising vertically with an acceleration of 4.9 meter per second square. Fine. Now releases a ball after 2 seconds. After the balloon is let go from the ground, right? Say the balloon has taken off. And it has reached a particular height from here, from the ground. After 2 seconds, he is going to drop a ball. Fine, he is going to drop a ball. Now, you are supposed to find what is the maximum height reached by the ball. Try to understand. You're supposed to find what is the greatest height above the ground reached by the ball. Right? Now, one thing I can find easily now. What is that one? That is, the height at which the ball has been dropped. I can clearly find the height at which the ball has been dropped, right? I can easily find that. How? Because I have, you know, uh, I have the value of acceleration, I have the value of time taken. I can find what is the height at which a ball has been dropped, right? Now, you can read the question one more time if you want. Try to understand the question clearly. Fine. A man in a balloon, a man in a balloon, rising vertically with an acceleration of 4.9 meter per second square, releases a ball after the balloon is let go. After the balloon is let go from the ground. After the balloon is let go from the ground. Right? Try to understand this one. Fine. Now, so its initial velocity is 0. The balloon's initial velocity is 0. The acceleration is 4.9 meter per second square. Time taken is 2 seconds. You can find what is the height at which the balloon is from the ground after 2 seconds. You can easily find that, right? So how to find it? Yes, S is equal to ut plus half at square, right? So it is S is equal to half A into T square, right? If S is equal to half A into T square, what is the value of A? It is given 4.9 clearly, right? So it is 0.5 into 4.9 into T square is 4, right? So I can write this one as 0.5 into 4.9, right? It is 1 divided by 2. How much is that? It is 2.45, I think. 2.45 multiplied by 4, right? 2.45 multiplied by 4 is how much? 2.45 multiplied by 4. So S is equal to 0 to 16 to 8, 1. So it is 9.8 meters. So the distance traveled from the height from the earth is 9.8 meters. Andre, the ball has been dropped from at a height of 9.8 meters in height. Now, try to understand one more thing. If the balloon is moving because it is moving vertically up, it must be moving with some velocity. If it is moving with some velocity vertically upward direction, then the ball is also moving upwards with the same velocity. Whatever the velocity with which the balloon is rising, with the same velocity the ball is also rising, right? Hagadra, I can find what is the velocity of the balloon. V is equal to what? U plus AT. Initial velocity is 0. So T is equal to V divided by A. V is how much? Sorry, V I am supposed to know. Sorry, V is V I am supposed to know. So it is 4.9. Sorry, 4.9 multiplied by 2, right? 4.9 multiplied by 2. How much is that? It is 9.8 meter per second. So at a height of 9.8 meters, the ball has been left with a speed of 9.8 meter per second, but in the vertically upward direction. So the ball has been thrown in the vertically upward direction. I want to know what is the height reached by the ball above that one, right? Hagadra, now, so V square minus U square is equal to 2A, right? From this point to what height does the ball will reach? After reaching the maximum, what is the final velocity? It is equal to 0, right? So U square, what is U? It is initial velocity, how much is the 9.8 square, right? So 9.8 square is equal to 2 into 9.8 multiplied by distance which I want to find. 9.8 and 9.8 will get cancelled. So S is equal to 9.8 divided by 2. So it is 4.9 meters. So the total distance traveled would be addition of both. That is 9.8 plus 4.9. How much is that? 9.8 plus 4.9, right? So it is 8 plus 9 is 17. This is 1, 10, 14.7 meters. So it is option A, 14.7 meters, right? Did you understand, right? You're supposed to think of a simple thing. What is that? If the ball has been left at a height, then the ball will also move with the same velocity. What velocity it has been left? With the same velocity it is going to move, right? Now, 9th one. A stone falls freely under the gravity. A stone falls freely under the gravity. The total distance covered by it, in the last second of its journey is equal to the total distance covered by it in the last second of its journey is equal to the distance covered by it in the first 3 seconds of its motion. Right? The time for which the stone is in air. Similar problem I have solved, but you are supposed to apply one more thing here. That's it. Right? What is this? A stone is falling freely under the gravity. The distance covered by it in the last second of its journey is equal to the distance covered by it in first 3 seconds. Right? Which equation now? You have to get updated now. Now I should not say completely and repeat itself again and again that this is what Sn you are supposed to use. No, nth second Sn, 3 seconds, third second Sn, 3 seconds yes, right? S is equal to ut plus half at square for 3 seconds. Third second is Sn, right? So let us apply this one now. A simple question to solve this one. Right? Now, yes. So Sn is equal to u plus a by 2 into 2n minus 1. Say n is the time at which the ball is going to travel its last second of its motion. Right? So now let's x be the distance traveled by it. X be the distance traveled by it. A obviously it is g by 2 into 2n minus 1. This is the distance traveled by it in last second. Right? Meanwhile, in a question they clearly say that this distance is equal to the distance traveled in first 3 seconds. So which equation? S is equal to ut plus half at square. Right? So S is equal to ut plus half at square. Since it has been dropped, u would be equal to 0. So x is equal to distance traveled is x, because whatever the distance traveled in the last second, it is equal to distance traveled in first 3 seconds. Right? Is equal to half into a is nothing but g into 3 square is 9. Right? So I can write x is equal to 9g divided by 2. So comparing both, simplify. Right? So it is 9g by 2 is equal to g by 2 into 2n minus 1. G by 2 and g by 2 will get cancelled. 9 is equal to 2n minus 1, or 2n is equal to 10, or n is equal to 5. A simple question to solve. Fine. Next. A particle is dropped under gravity from rest. A particle is dropped under gravity from rest. From a height h, and it travels a distance of 9h by 25 in last second. And it travels a distance of how much? 9h by 5 in last second. Fine. The height h is direct question, no? Direct question, nothing there is to simplify, right? So the last second Sn value is given. You are supposed to find what is the value of h, right? So let us see again. Sn is equal to u plus a by 2 into 2n minus 1. Right? What's the value of this? 9h by 25 is equal to u is 0. It is g divided by 2 into 2n minus 1. Right? I am supposed to find what? I am supposed to find what is the value of h? Distance. Correct? The total distance h value I am supposed to find. To find that, if I can find the value of time, then it would be easy for me to get the value of the total distance, right? Or h, right? So I am supposed to find the value of n, right? I am supposed to find the value of n. Fine. How to find the value of n now? Let us think. So to find it, I'll parallelize this is equal to ut plus half at square, right? Ut plus half at square. It has been dropped. So S is equal to a half, g into t square, right? I need to know this t, that is nothing but your n. Half n into n square. T square instead of t square, I'll write it as n square, right? How to find the value of n? Is there any other, hint given? Let us see. Is there any other hint given? Yes. Let us see now. A particle is dropped under gravity, right? A particle A particle is dropped under gravity, right? Dropped under gravity from a height of 9h divided by 25, right? Now, the only thing is I'm supposed to find what is the value of time taken. How to find that one? We have to simplify that. That's it. Nothing else is there. We're supposed to simplify that, right? How to simplify? How to simplify? Because I have two unknowns there, right? Since I have two unknowns, how to find that one? Let us see now. Now, so this is my equation number 1 and this is my equation number 2. Fine. Now, since this is height h, in the last second is going to travel a distance of 9h divided by 25, right? What is the remaining part? I'll think. What is this remaining? Obviously it is h minus 9h divided by 25, or simply 25 minus 9, it is 16h divided by 25, right? 16h divided by 25. Are you following? Now, the time taken to travel this is, if time taken is n second, this must be n minus 1 second. Are you following? If the total time is n second, then the distance, the time taken to this is n minus 1 second. Are you following? If this is n minus 1 second, then I can write this equation as what? I'll apply the same equation. What is that one? To travel 16h divided by 25, I have taken n minus 1 second. That is g by 2 into n minus 1 whole square. Equation number 2. Right? Equation number 2. Right? So what is this? Yes, obviously it is h. Right? If you divide both, g by 2 and g by 2 will get cancelled. H and h will get cancelled. So I can write n square divided by n minus 1 whole square is equal to 25 divided by 16. Right? Now, applying the square root on both the sides, it is n divided by n minus 1 is equal to, see, 5 divided by 4. Or, simplify this one, it is 4n is equal to 5n minus 5. Cross multiplying, right? n minus 1 will come here and 4 will come here. It's 4n. It is 5n minus 5, right? So I can write this one as 5n minus 4n is equal to 5, or n is equal to 5. That is, the total time taken to fall for a height of h is nothing but how much? Yes, 5 seconds. Substitute here. Yes, is equal to what? G divided by 2 into 25, or simply that is 10 by 2, it is 5. 5 and 25, S must be equal to what? 125 meters. Right? Right. So it is 122.5. So I have missed the point here. Just forget about that. 122.5, because since they have asked me to take G as 9.8, instead I have taken it as 10. So I have got this. So it is 122.5. Right? So option P must be your answer. Right? Let me go to the next one. Okay. So we have entered level 2 problems. Right? We have entered level 2 problems. Right? So what is this level 2 problems? Let us see. Now, a ball is dropped on the floor. The ball is dropped onto the floor from a height of 10 meters. From a height of 10 meters. It rebounds to a height of 5 meters. The ball is dropped from a height of 10 meters. It rebounds to a height of 5 meters. It rebounds to a height of 5 meters. If the ball was in contact with the floor for 0.01 second, if the ball was in contact with the floor for 0.01 second, what is the average acceleration during the contact? Very good. What is the average acceleration during the contact I am supposed to find? Right? See, what are the things I am having? Let us sort it out. You have been dropping a ball right? Yes. You have been dropping a ball from a height h, right? From a height of 10 meters. Just 10 meters. Fine. Now, it hits this one, it hits the ground and bounces back and reaches a height of 5 meters. And reaches a height of 5 meters. Now, I'm supposed to find what is the average acceleration during the time of contact. So what is the time of contact? The time of contact is 0.01 seconds. Right? The time of contact is 0.01 seconds. So what are things to be analyzed? A ball has been dropped, so initial velocity is 0. It is going to hit with a particular velocity. Then after getting in contact, it is going to raise with a height of particular velocity, and after reaching the height of 5 meters, again it is going to come to its velocity, that is equal to what? 0. Three things I said. One is while dropping, initial velocity is 0. While hitting the ground, it is going to obtain a velocity. Then while rebounding, it is going to have another velocity. Then after reaching the height of 5 meters, again its velocity would be equal to 0. Why? Read the question. A ball is dropped. Right? A ball is dropped from a height of 10 meters. When it has been dropped, what is its initial velocity? Its initial velocity is 0. Right? Its initial velocity is 0. Are you following it? Right? Its initial velocity is 0. Are you following it? Yes or no? You can comment with the chat box. Right? So now it rebounds to a height of 5 meters. And the ball is in contact with the floor for a time interval of 0.01 seconds. The time is in contact with the floor for 0.01 second. Right? Then what is the average acceleration? Average acceleration you are supposed to find. Correct? Now, how will you find that average acceleration? How do you find that one? So, acceleration can be found by two different things. One is s is equal to ut plus half at square, and the other one is v square minus u square is equal to 2as. To do both, you need to know what is the value of its velocity. Right? Let us find what is the velocity when it is hitting the ground first. Fine? In the first case, v square minus u square is equal to 2as. Initial velocity is 0. So v square is equal to 2 into 10 into 10, that is 100 into 2 is 200. So v square is equal to 200 meters. It's the initial velocity with which it hit the ground. It is going to rebound. It is going to bounce back. Right? It is going to bounce back with some particular velocity. Right? And it is going to reach a height of what? 5 meters, from which you can find what is the initial velocity of the ball. Right? With the same equation for the second case. Right? Now, v square minus u square is equal to 2a into s. Final velocity is 0. Initial velocity is what? Minus u square is equal to 2 into 10 into 5. So, it is minus again, obviously. U square is equal to what? 10 into 20. 20 into 5 is what? 100. So, v square is 200. U square is 100. Equation 1. Equation 2. Now, so in this time interval of how much? 0.01 seconds, right? I want to find what is the average acceleration. What will be? V is equal to u plus at. Right? V is equal to u plus at. Right? What is V? Square root of 200. How much is that? Approximately 19. Right? So 19 minus 10 is equal to a into 0.01, or a is equal to what? 9 divided by 1 in 10 power minus 2, or a is equal to what? It becomes 900 in 10 power. Right? Sorry, where exactly I went wrong? Just check once again. Just check it once again. No? Where exactly I went wrong? Yes. So it is 200 meters, it's correct. Then where exactly I went wrong then? Yes, so it is 10, so it is 14 square. Sorry, it is 14, no? Okay, this is 14, right? 14 minus 10 is 4. Okay, this is 4. Okay, so it is 0 point, so it is 4 into 10 power 2 minus 2, so 10 power plus 2, right? So it must be 400 meter per second square. Do I have the answer? Okay, something where I have went wrong then. Two into 10 into 5. 2 into 10 is 20. 20 into 5 is 100. Okay. So it is 100. This is 200. Okay. U square is 100. V square is 200. Then V minus U divided by T. Exactly. Right. So it is equal to V minus U divided by T. Then I must get the answer, no? V minus U is, V is 200 means approximately 14. This is 10. That is 4. Okay. 1 in 10 power minus 2. This is 4 in 10 power plus 2. So it must be 400. Right. Okay, so the answer must be 400 meter per second square. Fine. So this is how we are supposed to solve. Right. I might have typed anything wrong, so nothing to worry about it. Fine. Next, a point moves in a straight line. A point moves in a straight line. Moves in a straight line, so that its displacement x. So that its displacement x at a time t is given by x square is equal to t square plus 1. Its acceleration is, what is the value of acceleration? What you will do? Displacement is given, you are supposed to find the value of acceleration. What you will do? Differentiate twice, right? So x is given by, so exam QC. Sir, can you give the timetable of your timing? So for alternative days, I think it is alternative days it is 5 o'clock, evening 5 o'clock. Alternative days, right? So today it is 15, so 17 on odd days, 17, 19, 21, 23, 25, 27, 29. So this is how it goes. Every alternative days it is at 5 o'clock every day. Fine. Okay, so it is square root of see, t square plus 1. X square is equal to t square plus 1, or x is equal to what? Square root of t plus 1. So to find acceleration, you have to differentiate with respect to t. So dx by dt is equal to t square whole power 1 by 2 is there. I am supposed to differentiate this. So how to do that? So it is dx by dt is equal to half into t square plus 1 into half minus 1. So it is half into 1 by root of t square plus 1, right? Correct? Because it will be minus half, right? Minus half comes numerator, denominator, it becomes plus half, right? So now I got the value of v. V is equal to what? 1 by 2 into square root of t square plus 1, right? Now get me the value of a, that is dv by dt is equal to, dv by dt is equal to dv by dt. So 1 by 2 into x, t square plus 1 whole power minus half, right? Differentiate this. What happens? dv by dt is equal to, minus half into half, right? Into t square plus 1 whole power minus half minus 1, right? So minus 3 by 2 this becomes. So dv by dt is equal to, this becomes minus 1 by 4 into t square plus 1 into t square plus 1 into minus 3 by 2. See, how do you write minus 3 by 2 as? X into x power 1 by 2, correct? X into x power 1 by 2, that is t square plus 1 into t square square root of t square plus 1, right? So I can write this one as acceleration is equal to, so acceleration A is equal to minus 1 by 4 into, see, it is t square plus 1, so it has to be in denominator, sorry, divided by t square plus 1 into square root of t square plus 1, right? So root of t square plus 1 is x, this is x cube, so A is equal to, sorry, this is x square, so x square into x is x cube, so minus 1 by 4 x cube must be your value of acceleration, right? So minus 1 by x cube must be your answer, right? How 1 by 2? Root is there, no? X square is equal to t square plus 1 was given, right? So now how did I write this? X is equal to square root of t square plus 1, that's it. Then differentiating this, right? So this is equation. Say if you have x is equal to t power n, then dx to the by dt is equal to n into t raised to n minus 1. What is the value of n? It is minus half, so I took minus half here, into t square plus 1 whole power minus half minus 1, right? Minus of minus 1 is minus 3 by 2. I took it to denominator, right? So I wrote it as what? T power 1 by 2 into root of t square plus 1, t square plus 1 into root of t square plus 1. T square plus 1 is x square, root of t square plus 1 is x, so it is x cube. So it is acceleration is proportional to minus 1 by x cube. As simple as that. That is option D is your answer. It is proportional to. Fine. Keep that thing in mind. Fine. I'm going to continue this in my next class, that is on 17th. Fine. Stay tuned. Inform your friends regarding the class. Join Unacademy for the best of the courses. Thank you. Bye.